We are solving quadratic equations. Equations in the form of ax squared plus bx plus c equals y. Okay, and we found out that to solve them, what we're really asking is, if we graphed it, where does it cross the x-axis? Solving, you can just watch this if you want, means finding the x-intercepts. And that happens when your y value is 0. And so we've learned several ways to do it. The first one is to graph and look at it. Then secondly is to factor. That was on the quiz. Third was to complete the square and then solve by square roots. And the last way was the quadratic formula. And we liked this one because it always works. And what we've been doing for 3.6b, all of your answers were either like a nice number, like 3, so x is 3, or fractions. In this case, we have an answer of x equals 3, and then this answer would be x equals -2.5, okay, which would be a fraction. So we have whole numbers or fractions. Question, yes? Yes, go ahead. Somebody very gently do it back there. Thank you. All right. So for today, perfect, stop. Perfect. Today, we're also going to talk about solving with, put your phones away now. We're also going to talk about solving with the quadratic equations, but the answers won't be nice answers, okay? They could be like the square root of 2, okay? The square root of 2 is an irrational number, which means the decimal goes on and on forever. It's approximately 1.414 ... So it would actually be here, 1 point something. That would be the square root of 2. So the difference, the only difference between what we did 2 times ago and this time is that you won't get really nice answers, okay? And there are different ways this picture could look. It could look like this. It could cross in 2 spots. So you would have 2 solutions. It could cross in 1 spot. So you have 2 solutions, but it's the same number. Or maybe it doesn't ever cross. And in which case you have no real solutions, and we'll talk about that later. Of the real solutions then, just to clarify, they could be nice numbers, or they could, and fractions, or they could be irrational, things that are radicals that go on forever. Any questions with that? So we learned about this. Now we're going to learn about this. And there's actually a way to tell which type you're going to get called the discriminant, and we'll talk about that next time. So on that note, here we go. Steps to using the quadratic formula with irrational roots, which means your answers are going to look something like this. They'll have a radical in them. 1, move all the terms to the left side, so there's a 0 on the right side. I did that. 2, identify A, B, and C. A is 11. It's the first thing in front of x squared. B is negative 3. It's in front of the x. And C is negative 4. And then just like we did before, we are going to plug it in after we write the equation. So I wrote the blank formula, right? I took this and I wrote it out with parentheses. Everybody do that right now. Stop side talking. You would have put in negative 3 and negative 3. A is 11, C is negative 4, and the bottom is 11. Now you would put it in your calculator, which I know you guys have done this before. We started it last time. You would put, just so you remember, this part in your calculator. Okay, we want to put what's in the radical into your calculator. So you would have 3, because a negative and a negative makes a positive. 3 plus or minus the square root of whatever comes out of your calculator in just a minute, divided by 2 times 11, which is 22. Okay, so parenthesis, negative 3 parentheses squared, large minus, minus 4 times 11 times negative 4. And you should get 185. So again, as soon as you have this, we are going to check it and see what we get. The square root of 185. Oh, it's a decimal. So we're going to need to make a tree to simplify it, because this is your answer, but we want a better answer. So guys, let's make a tree. What multiplies into 185, and you can just start dividing. I see there's a 5 at the end. So 185 divided by 5, and I get 37. Now I think 37 is prime, but I'm going to check. 37, I know it won't divide by 2 because that's even. 37 by 3. Nope. 37 by 4, I know is not going to work. So, showing you how to check it, yeah. So guys, it's prime. So can we make a tree? Did the tree work? No. No, so guess what? There isn't a better answer. This is your answer. All right?
So you would put that just like that in the homework?
Yes. Yep.
And you wouldn't do like the 85 or like the 185 square root and like that?
No.
You're gonna put
The whole thing. Yes, I'm pretty sure your homework's going to make you separate it. Okay, guys, I would like you, as a group, to do number 2. Okay? When you have it done, I want you to stand up as a group and continue to work on number 3. As a group, do number 2. When you all have it done, stand up as a group and continue to work on number 3. We had to leave this like this. This is your answer because The square root of 505 does not make a tree that simplifies. Next, do number 4, and we will come back to 3. Did you get that? Okay, did 217 break down? No. All right, so you're done. Let's try a couple more. For this one, step 1 says get A, B, and C. All right, so we want ax squared plus bx plus c equals 0. So my A is 6, and my B is negative 22, and my C is 0, right?
No.
Yes, it is.
No. Right? The B goes in front of the x. Do we have any x here? So 0b, and our C is negative 22.
You guys, we cannot talk over you.
Does that make sense where that came from? If I were to guys, if I were to rewrite this, then it's obvious. This is my A, this is my B, and this is my C.
Why wouldn't the B be 22?
Because in order to have it be a B, you have to be next to the variable. It's not the order in which it shows up. All of the A's are in front of the x squared. All of the B's are in front of the x or whatever variable, and the C's are all by themselves.
Okay.
Okay, guys, let's just do this one together. We're going to do negative 0 plus or minus the square root of 0 squared minus 4. I don't know why you're talking, times 6 times negative 22 all over 2 times 6. So we have 0. We don't really need that 0 in the front, right? It's just gone. So we have plus or minus. And if I were to put that in my calculator, yeah, tell me what it is. What is it? 528. We could maybe be done, but we're going to try to do a tree with 528. Nah, fine. Okay, so here we go. 528 divided by 2.
It's
264. 132. But I'm wondering if any of these were perfect squares. Nope. Okay, and then we've got 2 and 66. 66 is 6 and 11. And 6 is 2 and 3. We are simplifying rational numbers. Look with your group once you have this on your paper and make sure you understand. Yes. So we have a pair of 2's, another pair of 2's, and we're left with a 3 and an 11. So we have plus or minus this 2. When we pull out this 2, 2 times 2 is 4. And then what do we have left in there? 3 times 11 is 33 divided by 12. That's better, but can you guys see anything that could divide farther? Guys, this is the same thing as plus or minus 4 over 12 times the square root of 33. What's 4/12? How does that simplify? 4 divided by 12. Math frac. 1/3. They can both be divided by 4. So 4 divided by 4 is 1. So we have plus or minus 1, the square root of 33, and you can ignore the 1. And 12 divided by 4 is 3. So the idea is, this is your answer. This was a better answer. This is the best answer. That's the previous one. All right, sorry. Good answer. This was your answer. This was a better answer. And then that was the best answer. The computer's going to want the final answer. All right. So guys, I think I would like you guys to do 6 with your group. Notice step 1 says that you need to get it equal to 0 first. So, no, 5 is just like the one we just did. Okay. As soon as your group has this one, stand up. Okay. You should have gotten this. Anybody have questions on this? Yes. Because I plugged in B instead of A. To see if you were paying attention, it should have been 3, and which would make this 6. Okay. Now the question is, do we have to make a tree? Well, 61 is prime. If you looked at it, here are all the prime numbers. 61, all the yellow numbers are prime, so I know I'm not going to get a tree. So that's Merry Christmas to me, because now I'm done. In the computer, you will put it in as the positive version and the negative version. All right, please get your pink paper out. Thank you.